Oh, hello everyone. Advent of Code Day 7, 2015. We're going to jump right into it. I'll make this music. Alright, some assembly required. This year, Santa brought Little Bobby tables, a set of wires, and bitwise logic gates. Unfortunately, Little Bobby is a little under the recommended age range, and he needs his help assembling the circuit. Ooh, this will be fun. Each wire has an identifier, some lowercase letters, and carry a 16-bit signal, a number from 0 to 65535. A signal is provided to each wire by a gate, another wire, or some specific value. Each wire can only get a signal from one source, but it can provide its signal to multiple destinations. A gate provides no signal until all its input have a signal. The included instructions booklet describes how to connect the parts together. X and Y, endpoint Z, means to connect wires X and Y to an AND gate and then connect its output to wire Z. Okay. So 1, 2, 3 to X means the signal 1, 2, 3 is provided to wire X. X and Y means that bitwise AND of wire X and wire Y is provided to wire Z. Okay, so we're going to need to learn bitwise operators here. Let me just do a quick Google search, bitwise operators Swift, because that's going to become very important. Operators Swift. Okay, Swift and bitwise with examples. A and B, bitwise operators. Okay, that's simple. Bitwise AND operator. I can apply this to, like, integers, right? Let me just double check. Swift. I'm going to run the Swift REPL. I'm going to do let A equals 1, 2, 3. Let B equals 4, 5, 6. A and B. Okay, A or B. Okay, yeah, that seems right. Okay, quit. Okay. Well, that was easy. A and B means bitwise AND operator of X and Y is provided to wire Z. P L shift 2 Q means that the value of wire P is left shifted by 2 and then provided to wire Q. Do we have lift shift? Is that a thing that we have in Swift? Here we go. Bitwise shift left. Bitwise shift right. Oh, nice. Okay, cool. Not E means that the bitwise complement of the value from wire E is provided to wire F. Do we have bitwise complements? Yeah, bitwise not. Ooh, it's a dash. Dash A. Okay, sweet. So this is gonna be very helpful. Thank you, programs.com. Okay, other possible gates include OR, bitwise OR, R shift. If for some reason you'd like to emulate the circuit instead, almost all the programming languages, for example, C, JavaScript, Python, provide operators for these gates. For example, if for some reason you'd like to emulate the circuit instead of physically building a circuit. Yeah, okay. For example, here's a simple circuit. After it's run, these are the signals on the wires. D, E, F, G, H, I, J, okay, X, Y. Little Bobby's kit instructions booklet provided to you as your puzzle input. What signal is ultimately provided to wire A? Okay, so we are going to have, I'm going to create a class, and it's going to be called circuit board, because this circuit board is going to own all the wires. So we're going to be able to query the circuit board for any signal on any wire, and then the circuit board is also going to own the relationships, I guess. Let's see. Okay, so we have our wires, and that's going to be is it going to be a character? Let's get puzzle input, make sure. Ooh, okay, so we have multiple letters. Okay, so it's not going to be single characters. Okay, so it's going to have to be a string to an integer, and the integer is going to be a numerical input. And this actually doesn't need to be initialized, so I'll initialize it as an empty dictionary. But it's not going to be... So just because there's a wire there doesn't necessarily mean it'll have a signal. Because as we know from the rules that the wire doesn't output a signal until all of its inputs are met. Okay, Little Bobby's kit, okay. Puzzle input, what signal is ultimately provided to wire A? So do we have to work backwards? Do we have to find wire A and then work backwards to get all of the things? Or do we just have to... let's emulate the entire circuit board, because puzzle 2 is probably going to need something. We're probably going to have to do something with it. Okay, so we have, let's see here. We need struct. Okay, let's define a struct for a rule. And that's going to be a rule. What does the problem call it? parts together. X means to connect. Okay, so that's not really, they don't have a name for this particular instruction, so I'm just going to call it a rule. Okay, so for example, we have, oh shit. Okay, so this is interesting. So now I need, some of these are going to have a first input. Some of them are going to have bitwise OR, R shift. So like, okay, this one, damn. Okay, so it looks like some of them are going to have, like, I guess we can start with this. Every single one is going to have this arrow with an output. Okay, so we have our output is going to be a string. It's going to be the output wire. Output wire. Okay. And we have var x and y. So we're going to have input 1. Input 1. Oh, wait a second. Let's do... can we do an enum of operator? And it'll either be case... Okay, yeah, I got it. It'll be case of and it's going to be let, it's going to be int, case or, int, case L shift, int, case R shift, int, case. So we have, assign. Yeah, let's do assign. Int. Okay. So assignment would be like, there is no operator. It's just a number, arrow, a wire. Okay. X and Y, L shift, not. Doesn't have a, anything. Okay. So, or R shift, if for some reason like to emulate, okay. Or and R shift. We have and, or, L shift, R shift, assign, and not. Not. Int. So assign is sort of the oddball because it doesn't actually have one of these words. It's just a number with an arrow. So if I look closely at the input, let's go back to the input. Do I have, is this it? Yes. No, that's the yesterday's input. Here we go. So everything has to the left of the arrow. If we're working backwards, so every input, every rule has an arrow with an output, and there's also either a wire or a string. Ooh, interesting. A wire or a numerical value that is the input, not GS. And, okay, so input or input, input or input. Oh, wait a second. I just realized this is not a, this could either be an integer or it could be a wire. It could be either one. Actually, assign. Now, hang on a second. Shift 3, not C. Okay, do we have anything that's like and where it has a static value? I don't think so. All of these and functions and or functions and R shift 5. Okay, so and, I'm going to change this. And is going to be string because it's going to be 2 wires. Okay. Or is going to be string because it's going to be 2 wires. This is probably going to bite me, but we're going to see where it goes. Okay, L shift, we start with a wire and we have an integer as the second operator. And same with R shift. We start with a wire and the integer is the second operator. Okay, string. And then assignment is just going to be an integer. It's always an integer. So for instance, like this one assigned to B. And then not is going to be a wire, right? I don't think we ever have a not with a let's look. Not. Okay, wire. Yeah, okay, I don't see any, these are all wires. These are not numbers. Okay, so I think that defines the puzzle input. So each rule is going to have an output wire, it's going to have an operator, and the operator is either going to be, it's going to be one of those 3 things, and depending on the operator that is in use, the inputs are going to vary. So like in the case of and, we'll have, or we'll have 2 wires. In the case of assignment, we'll just have the number. Okay, so now the rule is going to have a var operator, op. Okay, operator must be a reserved word, so I'm going to call it operator. Okay, nope. So this needs to be defined. Is this going to let me? Should be fine. Yeah. Okay. So I want to be able to init with a descriptor. This descriptor being the line from the input file. So input descriptor string. So, and then this, of course, is going to be the difficult part because now I need to write some kind of expression that can parse this out. So I'm going to say the operator is going to be everything to the left of the arrow. So the first step will be to get all the characters before and after the arrow, and then we'll be able to parse what's after the arrow very straightforward because it's just a string. Everything before the arrow, we're going to have to do something a little bit more convoluted. So here we go. So I'm going to do regex parse, and the regex expression is going to be a dot plus, and then we're going to have an arrow. It would need to be double escaped. And we're going to have dot arrow, and then a white space, and then a word character. Oh no, S, and then a word character. Actually, let's do this. I'm going to put it A dash Z, something A to Z. That's going to be the output wire. Let me just make sure that this is valid by opening debugX, my favorite regex debugger. Okay. Okay, regular expression is going to be backslash dot plus arrow and backslash S, and then A to Z, and plus. So at least one of A to Z, and it's going to loop, and it's going to keep going, and then let's see here. Oh, we do want a space here. And we do want to wrap this in a capturing group. And we also want to wrap this in a capturing group. Right? So now we have group 1 is going to be the leading. Oops, no, we do not want S plus. We want this plus. Okay? So we want anything, and then space, arrow, space, and then, so the backslash S is the space, correct? Backslash, a white space character, yes. So backslash S, we have a space, and then we have the wire output. So this should give me something. This should give me the groups that I need, the inputs and outputs. Okay, so let parse output equals. Let's just call it groups. Okay. And then we're going to run this on the descriptor string. And then, so then groups, if I build this, there's the argument parameter 1 in call. Oh, invalid escape sequence. Okay, that's the problem. That's right, because it's in Swift, I have to double escape these backslash characters. Ooh, no, this is actually incorrect. There we go. Group 2. Okay. So groups is going to be the first index. So we're going to do let operator input equals groups 0, and then self.output wire equals groups 1. So groups 1 is going to be the second part here. It's going to be this, and that's going to be our output wire. Actually, let's put that up on top. And then input operator. Let's do operation equals that, and then the operation is going to be, this is where things are going to get a little bit more tricky. So I'm going to write a regular expression, and it is going to how am I going to do this? Because I have, here, let's get some test input data. Where is the puzzle? Okay. Okay, 1, 2, 3 assigned to X. Okay, so this is going to be, so based on, okay, so it's, if it's going to be, oh shit, okay. It could be a, backslash D plus, and if it's just that, that could be a group. Otherwise, it could be a backslash word character with the word and. Ooh, I got it. and then backslash word plus. Right? Group 2, group 3. Or, oh, beautiful. Okay, I'm on the right track. So we have, and we're going to do or. We're going to do the same thing. We're going to get this non-capturing group. We're going to paste, and instead of and, it's going to be or. And so notice how this is group 1, group 2, group 3, group 4, group 5. So that tells me that the outputs are going to possibly be nil. So like, for instance, index 1 might be nil if it's an and. If it is an and, then input 1 will be nil. Group 2 or group 3 will be populated. And then group 4, group 5 will be nil. I hope that's how it works. That would be very useful. Okay. Another non-capturing group. Okay, so we have and, or we have L shift and R shift. So let's copy this. Get that whole argument there. We're going to paste it. Or, and that's going to be L shift. Okay. And that's going to be a word character and then numbers at the other end. Backslash D. So a word character is, ooh, no, wait a second. I only want letters. Okay. Okay, so let's do this. Instead of a W, well, what the hell? I'll just leave it. I'm going to trust the puzzle input to be kind of normalized. Okay, and we're going to pipe. We're going to do R shift. Okay, and then we're going to do another pipe. And we're going to do, okay, so we have and, or, L shift, R shift, assign is the group 1, and then not. I'm going to move assign to the top. That'll keep things nice and straight for me. Okay, so we have assign, and, or, L shift, R shift, and then the last one is going to be not. And the not operator does not have a first term. So this is going to say not, and then that. Let me double check the puzzle input. Not X, yep, okay. Oh, and that's not a digit, that's going to be a word character. Okay, so L shift, R shift, the second term is always a number. Yep, L shift 2, R shift 2. Okay, good. So now I'm going to copy this whole thing. Copy. I'm going to say let input groups. Actually, I bet I can, let's do this. I'm going to make it an initializer on the operator. Descriptor, string. We're going to do let, should I do here, static, private, static, function, let, the private static let, input groups, parse, input, parse descriptor, yeah, descriptor, parse regex, input parser regex, whatever, input parser equals regex parse. We're going to have this whole stinking big fat string. I have to make sure I double escape everything. Double escape these backslashes. Okay, almost done. Okay, now we do input parser. Operator dot input parser, and the input is going to be the descriptor. Let groups. Is that going to let me? Value of string must be unwrapped. Okay, yeah, so it does have the option to be, yeah. Oh, I see. So here's the thing I'm worried about is, let's do print groups. I'm kind of want to see, and we're going to do self, just for shits and giggles, I'm going to do self equals not empty string. Dot not, yeah, there we go. Okay, expression, okay, yeah, that's fine, I don't care. Operation, and we do self dot op equals operator operator descriptor groups 0. Okay, good. Now that should all be assigned. This is not used, but that's okay. Now just to see if everything is working, I'm going to create, let's just write the puzzle input and see what happens. I mean the test case. So for this case, we have this test case. Test case is A. So we have dot text. We're going to do a triple so we can do multi-line input. We're going to go like that. Expected output is going to be the wire on. Oh, that's aggravating. I don't know. This sample input doesn't have a wire A. Ugh, why did they do that? Okay. Well, anyhow, let's do input dot lines dot parse map transform rule dot init. Right? Let rules. Okay, and we're going to return unsolved. That's okay. Oops, that's not what I wanted to do. Quit. We'll need to copy and paste puzzle input so it's nice and cached. Copy. 7, day 7. Uh-oh. Illegal hardware instruction. What the hell? Whoa. Fatal error. Unexpectedly found nil when unwrapping an optional value. Okay. Puzzle Swift 62. Line 62. Whoa, really? Let's do this. Print. If I print the descriptor, that'll give me something to debug against. Fatal error. Groups 1. Oh, value of optional. Oh. Here, I gotta do that. Compile's okay. 1, 2, 3, arrow X. That arrow isn't like a special thing, right? A space and then A to Z. What if I do \W? Okay, the fact that that's failing tells me that this is not somehow any character, then a space, then an arrow. Okay, let's go back to debug X. Is that... None of those are special characters, right? I don't understand. That should work. What am I doing wrong? Okay, I'm going to copy and paste this. I got to get these double escapes back to normal. Okay. Does not match. How does it not match? The dot can be anything, right? Any character. Oh, but... Oh, it's the freaking back... Freaking idiot. You do not escape the dot character. Okay, that's what it is. Okay, now let's try. There we go. Test cases failed, but at least it ran without crashing. Build complete. Okay. Okay, okay. Optional XY, optional XY, X2, X2. Look at this. Okay, optional Y. Oh no. Oh no. I was hoping that it would divide up the, but it looks like it's doing a compact map. How does this regex parse work? Remove first. Oh, it does do a compact map. Shit. Is that what I want? What if I just do a regular map? Let's see what happens. Because what's happening is that it's filtering out the nil values, which is actually not what I want to happen in this case. I might have to make a new version. Uh-oh. It's going to say you can't compile because now it's returning an array of optional strings instead of regular strings. Okay. Declared closure result string is incompatible contextual type string. No, it's not. Actually, I changed it. Yeah, return ranges. Oh, I see. Oops. Build failed. Why? Oh, because now these are optionals. I'm probably going to have to just create a separate regex parse function because now, oh, see, now other puzzles are probably causing it to fail. Yeah, see, okay, I can't mutate this. I can't screw up this regex parse function because I can't change the signature because now it's causing other puzzles to fail to compile because it's already in use. So instead, what I'm going to have to do is regex parse option. I'm going to create a new function. And I'm going to call it, this has got to go back to compact map. Compact map. I'm going to do regex parse optional. And this is going to have an optional string array. And it's going to have a map here. And this is going to be an optional string. So just like that, we should have a tool that should work for our use case. So if I go back, and I go back to, let's see here. Regex parse. So this one I want to keep. This is the tool that I want for this job. But up here I want regex parse optional. Oops, yeah, optional. Okay. Groups. So now let's try again. Hopefully this returns groups with like nil values in between. Let's see here. Okay, so we have optional 1, 2, 3, nil, 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 nil. 4, 5, 6, nil, 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 nil. Optional X, optional Y. Nil. Perfect. Okay, so this is exactly what I need because now I can look at groups and I can tell if let assign in equals groups 0, then I can say self equals dot assign in. Else if let and 1 let and 1 equals groups 1, comma, let and 2 equals groups 2, then self equals dot and 1 and 2. Okay. Else if let or 1 equals groups 3, let or 2 equals groups 4, self equals dot or 1 or 2. Else if let else shift. No, but this is not a string. This is okay. So groups 0. Actually, I need to do assign in equals. Oh shoot. And assign in string, and then we do let assign in equals parse int like this, assign in str. I believe that returns a optional int. String must be unwrapped. Oh, okay. I'm gonna go like that. Okay. Yeah, L shift 1 equals groups 5. Let L shift 2 equals to str equals groups 6. and let L shift 2 equals equals int, because it's got to be an integer, L shift 2 string. Okay, self equals dot L shift L shift 1 int L shift 2 Is that allowed? I probably have to return here. I don't have to actually return the self equals, but oh, see. Okay. Oops. Okay, build succeeded. Okay, so I'm on the right track here. L shift, R shift 1 equals groups 7. Let R shift 2 str equals groups 8. Let R shift 2 equals int R shift 2 str. Self equals dot R shift 1, R shift 1, and then R shift 2. Okay. Last one is not. Else if let not was not 1 equals groups. That should be groups 9, right? We have 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And that's the last one. And that's going to be a string. Self equals dot not 1. Return. And if it gets this far, that means the input was invalid. So I'm going to say fatal error. I'm just going to say fatal error. Input invalid. Invalid. Okay. Okay, so I'm going to see if my rules are parsed correctly. And if they are, I think I'm going to have to call it a day because I have to get back to my day job. So let's go ahead and print rules. Let's see what happens. Input invalid. Okay, which input was invalid? Descriptor. Okay, input invalid. Why R shift 2? Why R shift 2? How is that invalid? Is my R shift, Y R shift, okay, 6, 7, 8, okay, okay, let's do print, let's print the groups. That doesn't seem wrong. Y R shift 2. Okay. 0, 1, 2, 3, 4, 5, 6, 7 is Y. And 8 is a string of 2. That's, yeah, R shift 2 string. I don't see the problem. Optional Y, optional 2, nil. Okay, 7 is R shift 1, R shift 2. Oh, stupid. It was valid. I just forgot to return. Duh. Now we're talking. Okay, so we have a rule, output wire X, operator, assign 1, 2, 3. Okay, next one, puzzle, rule, output wire Y, operation, assign 4, 5, 6. And the next one, rule, output wire D, and then operation is rule operator and X and Y. Okay, output wire E. We have operation is advent of code rule operator or X and Y. Okay, output wire F, and the operation is left shift X and 2. And then, okay, G is the output. We have right shift Y and 2. And then we have output wire H, and the rule is not X. And then same thing, we have output wire Y, rule is not Y. Okay, so that's as far as I have time to get today. I'm gonna go ahead and save my work. I'm going to commit. Yeah, come on, commit. Okay, progress on 2015. Day 7, incomplete. All right, so that's where I'm going to stop. Thanks, y'all, for joining me. I will pick this up tonight.